Welcome back to the Kubernetes Beginner's Guide, Lesson 06 of 13, and this is the one where K8 stops being a toy and starts being a real platform. Containers are ephemeral by design. Kill the pod, lose the data. Fine for a stateless web front-end, catastrophic for a database. So today we're tackling persistence. 4 resources, PV, PVC, StorageClass, and CSI, that decouple your pods from whatever disk is actually spinning underneath. Here's the roadmap, mapped straight onto the SRE loop you already know. We observe by learning the 4 resources and how they fit together. We diagnose by knowing when storage is static versus dynamically provisioned. That's where most pending PVCs come from. We act by picking the correct access mode, because RWO versus RWX will make or break your stateful set. And we document with VolumeSnapshots, your point-in-time backup story for stateful workloads. So let's meet the 4 resources, because this is the mental model everything else hangs off. A pod never references a disk directly. It references a PVC, the claim. The PVC binds to a PV, an actual piece of cluster storage. That PV gets created from a storage class, which is just a template pointing at a CSI driver, the real backend that talks to EBS, Ceph, or whatever's underneath. 4 layers, 1 job, hide the storage backend from the developer. And here's how that mental model plays out in practice. The admin defines a storage class once, fast SSD, backed by the EBS CSI driver, GP3 and encrypted. From then on, developers just write a PVC, give me 10 gigs, read-write once, fast SSD. That's it. The controller sees the claim, provisions a PV that matches, binds them together, and the pod mounts it. 5 steps, but only 2 of them involve a human, and the developer never touches AWS. Notice that the PVC asked for read-write once, and that's not a throwaway field. Access modes describe how pods are allowed to use the volume, and they're constrained by the backend. RWO is 1 node, read-write. That's your EBS, your PD, your Azure disk, and it's perfect for databases where a single pod owns the data. ROX is rare. Multiple nodes, read-only, think ML model weights. RWX means many nodes writing at once, and that only works on a real file share. EFS, file store, NFS, CPHFS. Pick a mode the backend can't satisfy, and the pod simply never schedules. Which brings us to the thing that actually fulfills those access modes, the CSI driver. Container Storage Interface is how Kubernetes stopped baking vendor code into its core. Instead, vendors ship their driver as pods. You install it with Helm, and a new storage class shows up in the cluster. The landscape splits cleanly. CloudBlock for your RWO databases, CloudFile for RWX shared workloads, and on-prem options like Rookceph or Longhorn when you want full control and accept the ops burden that comes with it. LocalPath and TopoLVM exist too, but treat those as lab grade unless you really know what you're doing. And once you have a CSI driver in place, you get something genuinely powerful for free. VolumeSnapshots. This is Kubernetes native backup, 3 resources working together. The VolumeSnapshot class is a one-time setup pointing at your driver. The VolumeSnapshot itself is the point-in-time capture of a live PVC. And to restore, you don't overwrite anything. You create a brand new PVC with the snapshot as its data source. Same disaster recovery pattern we use for etcd. Snapshot, ship it off cluster, and actually test the restore. A backup you haven't restored isn't a backup. So let's consolidate everything into 6 reflexes. Habits that turn storage from mysterious to manageable. Start every storage investigation with kubectl getPV PVC-A. The status column is your diagnostic. Set a default storage class, so developers stop pasting boilerplate. Set reclaim policy retain on anything production, because the default is delete, and a fat-fingered kubectl delete PVC takes the disk with it. Use allow volume expansion to resize live. When a PVC hangs pending, describe it and read the events. And run a snapshot and restore drill quarterly. That's the muscle you need before the outage, not during it. And here's the whole lesson on one screen. 12 patterns to pin somewhere you'll actually see them. The left column is your daily inspection. List classes, list drivers, set retain, restore from snapshot. The middle is the shape of storage itself. What exists? Which access modes? Can it grow? And the right column is your safety net. Diagnose pending, know your default, and snapshot before you regret it. Screenshot this one. Now, the 5 mistakes that will actually bite you. Number 1 is the silent killer. Dynamic PVs default to reclaim policy delete, so deleting a PVC nukes the underlying disk with no recovery path. 2 and 5 are the same lesson from different angles. Block storage is single node, so asking EBS for read-write-many or mounting one volume to multiple pods gets you pending forever or a multi-attach error. 3 is the Helm chart classic. No storage class name, no default class, PVC hangs. And 4 is the one that ends careers, snapshots in the same region as the volume aren't disaster recovery. Snapshot, then export off region, always. Theory's done. 3 exercises to burn this into muscle memory. First, run a PVC end-to-end on kind, apply, watch it bind, mount it, write a file, kill the pod, see the file survive. That's the 5-minute click moment. Second, break a PVC on purpose, wrong storage class, then read-write-many on local path. Read the events, fix each one. That's mechanical debugging instead of panic. Third, the snapshot and restore drill. Same DR muscle as the etcd restore from lesson 04, but for application data. Do all 3. The drill is what matters. And that's lesson 06 in the bag. Storage is provisioned. PV, PVC, storage class, CSI, the access modes, and the snapshot drill all live in your hands now. From here, the series shifts tag. Daily fundamentals give way to advanced. Lesson 07 is scheduling, affinity, taints and tolerations, topology spread, resource limits, how Kubernetes picks a node, and how you take that decision back. See you there.